Welcome back to Learn Physics Math Edition. In this video, we will see the introduction about Chapter 4, Quadratic Equations from Class 10 Mathematics. Okay. So first, we will see any equation which is in the form of ax square plus bx plus c. Okay. So this form of polynomial is called quadratic polynomial, which means if the degree of the given polynomial is 2, then the polynomial is said to be quadratic. Okay, that's the only thing you have to remember. If the degree of the given polynomial, degree means the highest power of the variable. Here the polynomial variable is x. So if the highest power of x in the given polynomial equation is 2, then the polynomial is called quadratic polynomial. Okay, so if you write this in equation form like this, ax square plus bx plus c is equal to 0. If you equate this polynomial to 0, then it is called quadratic equation. Okay, so it should be in the form one term with x square, it is compulsory, it should be there, and remaining two are optional, it may or may not be there. Okay, a, b, c here are called constants. A, b and c are any real number are constants. Okay, some criteria are there for a quadratic equation. The value of b and c can be 0, but value of a should not be equal to 0. If the value of a is equal to 0, so what will happen? 0 into x square. So instead of this a, I have replaced with 0 plus bx plus c equal to 0 will be there. So 0 into anything is 0, so we will be left with only bx plus c. Now the power is reduced to 1. Okay, so we cannot call this as a quadratic equation if the degree is equal to 1. Okay, we know that quadratic equation must have the degree as 2, but in this case if the value becomes 0, value of a becomes 0, this equation is reduced to a polynomial with degree 1. Okay, so we call this as linear equation. Okay, we call this as linear equation. Clear? Whenever the coefficient of x square, that is a, becomes 0, then the given polynomial no longer would be a quadratic polynomial. Okay, so just remember this. Let me recall the things that we have seen. Ax square plus bx plus c is equal to 0. That is a general form of quadratic equation where a, b and c are constants. The value of a should not be equal to 0. Should not equal to 0. Okay, but value of b can be 0 or value of c can be 0 or both a, b and c can be 0. But the only criteria is the value of a should not be equal to 0. Okay. Let us see some example for the quadratic equation. 3x square plus 4x plus 8 is equal to 0. Okay, here the value of a is 3, value of b is 4, c is 8. Okay, and this is in the form of ax square plus bx plus c. Any equation in this form is called quadratic equation. Okay, so let us see one more example. 2x square plus 5 is 0. But this is also quadratic equation, but let us find the value of a, b, c here. Value of a is 2, b is 0. There is no term with x here. So b is nothing but coefficient of x. Okay, in the general form you can see b is nothing but the coefficient of x, the number just multiplied with the x. But here there is no term involves x. We have x square and a constant term. Okay, but there is no term with x. So we can, the value of b is taken as 0 and the constant term value is 5. Okay, and a is not equal to 2, sorry, a is not equal to 0 and the degree is equal to 2. So we can call this as a quadratic equation. Okay, let us see one more example. 3x square plus 5x is equal to 0. In this case we have the coefficient of x square, that is a, and the second term we have coefficient of x as 5, that is b value, and there is no constant term, so we have to take that value as 0. You just compare the given equation with the general form, Okay, the coefficient of x square is a, here the coefficient of x square is 3, okay, and then coefficient of x is 5, here the x is b, so b value is 5. There is no c term here like that one in the general form, so we can take c value as 0, okay. So all you have to remember is just two things: degree of the quadratic polynomial, degree of the polynomial should be equal to 2, okay, this is the first point. And second point, the coefficient of x square, coefficient of x square, that is a value, should not be equal to 0. If these two criterions are satisfied, then the given equation is called quadratic equation, okay. And one more thing, you have to know how to find the value of a, b and c from the given quadratic equation, okay. So like this, if you want to, you can pause this video and note down this. So next one is zeros of a quadratic polynomial. In general, if you have a polynomial like this, a linear polynomial like this, 3x plus 3, okay. Now we have to substitute a value of x, value for x, so that the entire equation value becomes 0. So in this case, I can put x is equal to minus 1, so I will get p of minus 1 is equal to 3 into minus 1 plus 3. So 3 into minus 1 is minus 3, and the plus 3 will come here, so it will become 0, okay. So if you substitute x is equal to minus 1, this entire p of x becomes 0, okay. If you substitute x is equal to minus 1, the entire equation is 0, okay. For a specific value of x, the given polynomial becomes 0. That value of x is called root or 0 of the given polynomial. This equation is a linear equation, so it has only one root, okay. If it is a quadratic equation, its degree will become 2, so it will have two roots. If it's a cubic equation, its degree will become 3, so it will have 3 roots, okay. So the maximum number of zeros of a polynomial is equal to the degree of that polynomial, okay. Next, we will see a polynomial equation with degree 2, that's quadratic equation, x square minus 5x plus 6. Here also we have to put a value for x, so that the entire equation will become 0. So I am replacing x with 2, so I will get 2 square minus 5 into 2 plus 6. So 2 square is 4, minus 5 2s are 10, plus 6 will be there. So I will get 4 minus 10 is minus 6, and plus 6 will be there. The answer is 0. Now the x is equal to 2 satisfies the given polynomial equation. So x is equal to 2 is a root, but the degree of quadratic polynomial is 2. We need another root, right? So let's put some other number in the place of x, okay. Here I am choosing 3. So let's see what we will get. 3 square minus 5 into 3 plus 6. 3 square is 9 minus 15 plus 6. 9 plus 6 is 15, minus 15 is there, and we will get 0. In this case also, the entire equation becomes 0. So we have two values for the degree 2, okay. So x is equal to 2 also satisfies the entire equation, x is equal to 3 also satisfies the entire equation, okay. So these two are called zeros or roots of the quadratic polynomial, okay. So far we have seen the introduction to quadratic polynomial and their zeros that we have seen. Now we will see how to find the roots of a given quadratic equation. So let us take an equation x square minus 5x plus 6 is equal to 0. To find the roots of this equation, first we have to identify the coefficient of x square, okay. If there is any number in front of it, you can directly take that number as coefficient. If there is no number like this, we have to put 1, okay. If some number is there, you can directly take that number as it is. You don't have to do any changes in it, okay. Clear? Now you have to multiply this 1 with the last term and the constant term. So 1 into 6 will be 6. Okay, just put the number here, and what you have here, you have minus 5 here. Just put that number. Okay, just write that number at the bottom. Now you have to write two numbers in these two places so that their sum should be equal to minus 5 and their multiplication value should be equal to 6. So I am going to write minus 2 here and minus 3 here. So minus 2 into minus 3 will become plus 6, and minus 2 into minus 3 will become minus 5. The product of these two numbers is plus 6 and the sum of these two numbers is minus 5. Okay, so I'm going to write this minus 5x instead of minus 2x and minus 3x. This is what I found. Okay, instead of this minus 5, I'm going to split this into two parts, minus 2 into minus 3. That's what I have written here. Next, we will write the next step, x square minus 2x minus 3x plus 6 is equal to 0. Now you have to take a term common from the first two terms and the common term from the next two terms. Okay, so just write this as it is. Here we have x into x. In the second one we have minus 2 into x. In the third one we have minus 3 into x. In the last one we have minus 2 into minus 3. Okay, here I have minus 3, right? So I have written in the last term also in terms of minus 3. Okay, now we have to take a common term from the first two and the last two also. Okay, from the first two, what is common? You can notice x is common. If you take the x from the first one, you will be left with another x. If you take x from this one, you will left with the minus 2. This part is over. Okay, in the second term, you can see which one is common. Minus 3 is common. Okay, if you take minus 3 from these two parts, you will be left with x in the first term and minus 2 in the second term. Okay, now you can see the terms inside the brackets are exactly same. You have to make sure that these two terms should be exactly same, otherwise your step was wrong. You have to take a negative sign outside this term also. Okay, initially we had 4 terms, now we reduce that into 2 terms. Okay, now we have to take the common between these two terms. So which one is common? You can see x minus 2 is common. If you take x minus 2 from the first term, you will be left with only x here. If you take x minus 2 from the second term, only minus 3 will be there. Okay, that is equal to 0. Now you can equate these two terms to the 0 individually. So x minus 2 equal to 0, x is equal to 2. Minus 2 will become plus 2 if it goes to the right side. X minus 3 equal to 0, x is equal to 3. These are all the two roots of the given quadratic equation. Okay, you have to be careful while reducing the term, and you have to make sure that the terms inside the bracket in the step should be exactly same. Okay, instead of doing all these things and finding the answer, we can directly find the answer. So what you have here, x is equal to minus 2. Just change the sign, so you will get x is equal to plus 2. So what do you have here, x is equal to minus 3, x is equal to plus 3. Okay, so these two are the required roots. So this will exactly match with the values that we found using the steps. Okay, clear? This is one method, and let us see one more question. 3x square minus 15x plus 18 equal to 0. In the first step, we have to identify the coefficient of x square and multiply it with the constant term. So 3 into 18 will be 54, and the next one is minus 15 we have here. Just put the minus 15. Now you have to put two numbers so that their multiplication should be 54 and their sum should be minus 15. So you have to write minus 9 into minus 6. So minus 9 into minus 6 become 54, and minus 9 plus minus 6 will be minus 15. So that you can split this into two terms, 3x square minus 6x minus 9x plus 18 equal to 0. Now we have to take a common term from the first two terms and common term from the last two terms. Okay, so we can see 3 into x is common. You will be left with x minus 2 in the bracket, and if you take minus 9 out of the bracket, you will be left with x minus 2. Okay, so to verify this, you just multiply the minus 9 into x become minus 9x, minus 9 into minus 2 will be plus 18. Okay, you will get the same term on the previous step. Okay, now you can notice x minus 2 and x minus 2 are common. You can take that out. If x minus 2 is removed from the first term, you will get 3x alone. In the second term, you will get minus 9 alone. Okay, now you can equate these two terms to 0. So x minus 2 is equal to 0, or 3x minus 9 is equal to 0. So x is equal to 2 and 3x is equal to 9. Minus 9 will become plus 9 and 3 is in multiplication here. If it goes to the right side, it will become the denominator. So you can cancel these two. You will get 3. X is equal to 3. So that is the root. Okay. In this case also you have shortcut. So what do you have here? Minus 9 and minus 6. So instead of this minus 9 and minus 6, you just have to change the sign so that you will get 9 and 6. Okay. Now you have to divide that with coefficient of x square. In this case, the coefficient of x square is 3. So I am dividing that with coefficient of x square so that you will get 3 and 2. So these two are the roots, x is equal to 3 and x is equal to 2. That's what you will get here. Okay. Clear? So if you have nothing in front of the x square, you can directly change the sign and write them as root. Okay. If you have any number in front of the x square, you have to change the sign and divide that by the coefficient of x square. Okay. So this is the normal method, and we have one more method, that is formula method. Okay. We will see the same question in the formula method also. So let us write the number here. The last question what we have seen, 3x square minus 15x plus 18 equal to 0. To do the formula method, you have to find the value of a. Value of a is 3, value of b is minus 5 and value of c is 18. The formula is minus b plus or minus b square minus 4ac divided by 2a. This is the formula. Just write the value here. What is the value of b here? B value is minus 15. Already a minus is there. Minus into minus 15 and plus or minus. What is b square? B square is minus 15 square and 4 into a value is 3 and here you have c value is 18 and 2 into 3, a value is 3. Okay. Just remember this formula, minus b plus or minus root of b square minus 4ac by 2a. Just find the values from the given quadratic equation and substitute in it. That's the easiest step you have. Now you can simplify this. Minus into minus 15 will be plus 15 plus or minus remains as it is. Minus 15 square will be 225 and 3 into this will be 54. 54 into 4 will be 216. Okay, minus 216 divided by 2 3s are 6. So x is equal to 15 plus or minus 225 minus 216 is 9 and here you left with 6 in the denominator. Now you can put x is equal to 15 plus or minus root 9 value is 3 and 6 will be there. You have two signs here, plus and minus. You have to split this into two equations, the one with the plus and one with the minus. And here you have 15 minus 3 by 6. So x is equal to 18 by 6 and x is equal to 12 by 6. Okay. Now you can, 18 by 6 is nothing but 3. Okay. In this case you will get 2. Okay. So this method is a little bit complicated one, and one thing is sure, this method is suitable for all kinds of quadratic equation except some equation will yield a negative value in this part. Okay, for that case alone we cannot use this method. Okay, otherwise this method will work fine for each and every quadratic equation. Okay, clear? In the next video we will see the discriminant and nature of roots of the quadratic equation and few previous year questions also. Okay.